Hi everybody, Patrick here from EngineeringShock.com, ElectronicLessons.com, and PaintballProps.com. This is tutorial number 5 for my current Kickstarter campaign, the Arduino Protoboard. I've got a lot of hookups here. A lot of them are for other projects, but what we've got here is a continuation from our last video. In our last video we made a clap-on, clap-off circuit. In this video we're going to talk about how to make a clap-clap-on, clap-clap-off circuit. The code's a bit more in-depth, but not much. Again, we only need our microphone circuit talked about in our last video, linked below, but we'll go over that circuit, the hookups. Again, we'll go through that all again, and we'll go over the code in just a minute. But if I clap once, nothing. Clap once, nothing. Clap twice, and the LED turns on. And it stays on until I clap off. So let's talk about the schematic and the hookups. We've covered this same circuit in our noise detector tutorial and in our clap-on, clap-off tutorial. So if you haven't seen those videos, check them out below. I talked to them certainly in more detail, but I'll go over it quickly again. An electret microphone, the positive is connected to a 10k ohm resistor, which is also connected to the 5-volt line, and the negative pin of the electret microphone is connected to ground. When the electret microphone senses an audio signal, it couples that AC signal across to the other side of C1, which is a 0.1 microfarad ceramic capacitor. And this capacitor also acts to block the DC element on the left side of the circuit. That AC signal is fed to the A0 line, and there is a 4.7k ohm bleeder, which also acts as a filter, but that's not really necessary here. The larger that resistor, the higher the sensitivity. So you can change that, and you can also change sensitivity in software when you do your if analog value equals or is more than 2. You can make it less sensitive by saying more than 4. In any case, let's talk about how to connect this to your protoboard. This is the exact same hookup as our clap-on, clap-off video. We're going to connect both grounds from our microphone circuit to the ground line in black. We're going to want to connect the L1 pin at the bottom to GPIO2 in blue, and L1 corresponds to LED 1 on the lower left. We want to connect the output of our microphone line, our circuit, the coupled AC line, to the A0 pin in yellow. And lastly, we want to connect the top of the 10k ohm resistor to the 5-volt line. And then you're ready to go. You just need to program your chip, place it in the socket on the upper left, and we're off to the races. We're going to talk about this code in 2 segments. We're going to talk about the beginning, the void setup, and the void loop, at least half of the void loop, down to the else statement right at the bottom of the page. We're going to stop there, and we're going to restart at that else statement. First of all, if you have watched our previous 2 videos, we're going to create an integer called analog value. It's a register. It's going to act as a register, and we are going to store analog to digital converter readings into analog value. We're going to define our LED, to GPIO2. So we're just going to call it LED, and we're going to associate it with GPIO2. We're going to create 2 Boolean functions, one called toggle and one called second. And second essentially stands for second clap. Everything is commented here. In our void setup, we declare our LED as an output, so GPIO2 drives the LED and it is an output. And we want to start off in a state where we do a digital write LED low, so the LED is off by default. Now we go into the void loop, and the void loop is set up in 2 different sections, one large if statement and one large else statement. It's toggle. Our Boolean function will either be true or false, and we've set it to false by default, so only the if statement will be at the top will be executed, whereas the else statement at the bottom, which we'll talk about in the next section, will not be executed until toggle equals true. So by default, digital write LED low, turn the LED off. It's already off, but we're going to use this later. Analog value equals analog read 0. So what this does is it takes a reading off the A0 line and turns it into the analog signal from the microphone, changes it into a digital signal, and places it in analog value. If analog value is greater than 2, we've heard a clap. After that, we wait 150 milliseconds, delay 150, so we wait a minimum of 150 milliseconds before scanning for the second clap. Now we have a for statement. So in this for statement, we want to check 200 times at a 1 millisecond delay every single check for a second clap. So if analog value, we take another sample off the A0 line and it equals, it's greater than a value of 2, then second equals true. So second, our Boolean function, which was previously false, is true. If after checking 200 times second is true, we change our toggle Boolean function to true, which was previously false, and we change our second Boolean function back to false. So what this has done is, if a second clap is detected during those 200 checks, we turn our Boolean function second to true, and then the next if statement, if second equals true, toggle equals true, second equals false. So we're changing that second Boolean function back to false, which is essentially just an indicator that a second clap has been detected. Then we wait a minimum of 200 milliseconds, at which point we go back to the top of void loop. But now toggle is true, not false. So the if statement the large if statement is completely discarded, and we go down to the else statement. We're still going to see some of the code above, but we're going to start mid-page on the large else statement. Now this else statement is almost identical to the if statement, but now our toggle Boolean function equals true. So if at the top of void loop, if toggle equals false, perform the if statement, else perform this section of code. At this point, we're going to turn LED high, because as long as toggle equals true, that LED will stay on. At which point we take another analog read, another sample from A0, the A0 line, and place it into analog value. If analog value equals more than 2, one clap has been detected. Wait a minimum of 150 milliseconds, and then do 200 checks using the for statement to determine if a second clap has been detected. Each check has a 1 second delay, so this is essentially a 200 millisecond window where you can get a second clap. During that for statement, if analog value equals true after taking an A0 reading, then our Boolean function second equals true. Then the bottom if statement there will proceed. If second equals true, then change our Boolean function toggle back to false, change our Boolean function second back to false, and we'll wait a minimum of 200 milliseconds, at which point the void loop will repeat, only now toggle is false. So the if statement at the top of the void loop will execute, whereas the else statement will not. Everything is commented out. All of this will be available to you if you pledge towards a Kickstarter, but I'm sure even if you don't want to pledge towards a Kickstarter, you can still make sense of this, especially with all of the comments. So that's that. It's pretty easy to do. Again, anyone who pledges towards a Kickstarter campaign will have access to this code. If you don't need to pledge towards a Kickstarter, you can look at the code, make sense of it in this video, and move forward with your own circuit if you'd like. But just wanted to mention that all the code samples will be included with the Kickstarter pledges. So again, and you can adjust sensitivity as you see fit. So thanks for watching. Hope you'll check out the Kickstarter link below. Have a great day, everyone.